Hello everyone, this is our 14th class. Today we are going to learn about flowchart, which is a very basic thing for programming logic. This class is not only for Blue Jay or Java student, for all those who want to learn programming from basic. So welcome to Classroom Computer. Let's start. As per theory, flowchart is a schematic representation of a sequence of operation, but technically it is a graphical or diagrammatic representation of sequence of operation. It actually visually represents the flow of data in a program. That means if you observe carefully a flowchart, then you can identify the sequence of operation in a program. It also can be used to represent algorithm. Algorithm is a very basic thing for computer programming. It will take some bunch of classes at the time of data structure, but not now. Flowchart, first introduced by Frank and Gilbert at 1921. The final look, which we are discussing today, explained and fully developed in 1949. Just because it's a diagrammatic or symbolic representation, so let's talk about the symbols. Those are the symbols used in flowchart. This is a total list of symbols, and those highlighted symbol in red, those are only we are discussing today, and mainly those are only necessary for flowchart in programming in very basic way. So highlighted symbols are process, decision, data, document, multi-document, terminator and connector. The first symbol is terminator. This is a start or stop point in a process or program. Sometimes it's also called terminal, represented by an oval or rounded rectangle. They usually contain the word start or end or stop, and this symbol is mandatory. But there can be only one start and only one stop in the entire flowchart. The next is data. Somewhere it's also called input-output. It indicates of inputting and outputting of data, represented by a parallelogram. This input can be done through keyboard, tape, card, reader. Similarly, for output instructions, the output device may be screen, printer, plotter, magnetic tape, disk, etc. In computer programming, normally the input device is keyboard and the output device is screen or printer. The next is document. The first one is single document, represented by the first one, and the second one denoted for multiple document. This is actually hard copy. The first symbol is a rectangle with wavy base, and the second one is a stack of rectangle with wavy bases. In some flowchart, output operation denoted by this instead of that parallelogram. That means the output is in paper, hard copy, in a form of report. The next one is process. The symbol is rectangle. All mathematical calculation like addition, subtraction, multiplication, division, etc. done here. The logical process of data movement from one memory location to another also represented by this processing box. Multiple instruction can be represented in a single processing box. The next is decision. This is a logical symbol. Generally, this symbol is used to ask question that can be answered in a binary format. That means yes or no, or true or false way. The input is single but the output is double, because the answer can be yes or no. So the output represented by or denoted by rhombus. And this one is connector, represented by a circle. It allows the flowchart can be drawn without inserting the lines or without reverse the flow. Actually, it cuts one big flowchart into more than one flowchart. This is also called one page connector. The last one is arrow. Those lines are called flow lines. They shows the direction of flow in a flowchart. Better to say the direction of logic flow in the program. Those lines coming from one symbol and point to another symbol. In this picture, the third line is bidirectional. That's my mistake. You never saw a flow line which is bidirectional. So please ignore the third one. In today's class, we are going to discuss about three types of flowchart. First one is sequence, the second one is branching or selection, and the third one is loop or repetition. This is the first example of sequence flowchart. This is a very basic flowchart for sum of two numbers. Here the first symbol is start. In sequence type of flowchart, all statements place one after another. Top-down approach follows here. Terminal, input, output, processing box, use here. Here is an example, sum of two numbers. Now the first symbol is start. Then read two numbers. In flowchart, we have to take variables to store numbers or data. So here to store two numbers, two variables are a and b, and another variable sum where we store the sum of a plus b. So the second symbol is input symbol where read or input a and b. Next, the processing box in third, sum equals to a plus b. Now the time for output, print the sum. So another input output box, and after that the program ends. So the oval shape box come with end. So this is a very basic example of very simple, very easy flowchart. Now come to another example of sequence type of flowchart where we calculate the Celsius. Actually we convert from Fahrenheit to Celsius. Okay, here the first symbol is start. Next, convert Fahrenheit to Celsius. So we have to take input the temperature in Fahrenheit. So we take input using input output box. The next work is processing to convert the value from Fahrenheit to Celsius. So rectangular processing box is here. After that we have to print the value in Celsius. So we use another input output box. We store the converted temperature into the variable C. So we take another input output box to print the value of C, and after that the program stop. So we use another terminal symbol with end. You can also write stop here. For example, you can also study this flowchart for area of a circle. This third one is another example of sequence type of flowchart. Here only processing box value is different because here we calculate the area of a circle, not converting some temperature or adding some values. So this input is same, the output is same, only the processing area is different because here we calculate the area of a circle. This is the next type of flowchart, which is branching or selection. In this flowchart actually represents biggest among two numbers. What is the general concept? That user the in for two numbers, let they are a and b, and we have to compare their values. This flowchart actually compare if a greater than b or not. But in branching we actually compare less than or greater than, equal or not equal. This thing can be done using if else in algorithm or programming language. So we use decision box here. Here is a decision box. Decision box always have two output hands, one for condition true and another for condition false. In case of this flowchart, we are going to find bigger number among two numbers. So at first take two numbers at very beginning, use the terminal start. Next, input box to take two numbers or read two numbers. Next is the time for comparison. If the first number is greater than the second number, that means if A greater than B, then it goes with true hands and print A, and after that it ends. But if A is not greater than B, then B is greater than A and it goes to the false hand and then end. But there is a problem. This type of problem in programming we call bug. That means an exception. An exception case where this flowchart or program based on this flowchart may not work. Why? Because if we input A equals to 7 and B equals to 10, then this flowchart works fine. Or if we input A equals to 10 or B equals to 7, then this flowchart also works. But if we input A equals to 7 and B equals to 7, that means both values are equal, then this print statement, print A and print B, those are not justified. So I just edit this flowchart in a better way. This one. Here you can see, after taking input A and B, I first compare if both are same or not. If both are same, then I print both are same, no one is bigger. But if both are not same, that means I am going through the false hand, both are not same, then I calculate if A greater than B, yes, then true hand, print A and the program ends. And if A greater than B is false, that means B is greater than A, and after that the program ends. Whenever you write a program, then you have to think that your program should show or print or give output properly for every input value. So whenever your program doesn't show proper output or this type of problem occur, then we say your program contain a bug. So I remove the bug that both numbers are same or both values are same. Then here also a way, an option that can show, okay, yes, no one is bigger, both are same. Here is the last type, which is loop or iteration. This is a very interesting thing because only this type of flowchart where loop is running, the flow line go backward or upward. Let's see an example. This program is for sum of first n natural numbers. So start from first, after start, then input box, then first read the value of n. Flowchart is sum of n numbers of natural numbers. So it's like 1 plus 2 plus 3 plus 4 plus 5. So we have to take the value where you want to stop. If I want to stop at 5, then 5 is the value of n here. In next processing box, I write sum equals to 0 and I equals to 1 and n equals to 5. Now in next decision box, there is a checking that is I less than equals to n or not. But here I equals to 1 and n equals to 5. So the condition is true. So it goes through the true hand. There sum equals to sum plus I. The value of sum was 0 plus the value of I, which is 1. So 0 plus 1 equals to 1. Next, increase the value of I with plus 1. So I equals to I plus 1. Now the new value of I equals to 1 plus 1, which is 2. Now the interesting thing is, after this processing box, the arrow goes backward and check again that is I less than equals to n. Is it true or not? This thing is called loop. In every iteration, the value of I increased with plus 1 and the sum accumulated the value into with addition. Whenever the value of I equals to 6, when sum equals to 1 plus 2 plus 3 plus 4 plus 5 and the new value of I is 6, it goes backward and check in the decision box, but the value of I is 6 now, but the value of n is 5. So this comparison is not true. So it goes to false and print the value of sum, which print 1 plus 2 plus 3 plus 4 plus 5 when the value of n is 5, and after that the program ends. This is loop. This is a very basic loop. Normal program contains very complicated, very nested type of loops. Whenever I discuss about loop in programming, then you can see, if you have a good knowledge of flowchart or algorithm, then every logic or problem is very easy to solve and the way is very clear. If you have a good knowledge, a basic knowledge, a very clear basic knowledge in flowchart or algorithm, any one of them. Now some theory part. General rules. The first rule is all boxes of flowchart are connected with arrows, not lines. That means they should have some direction. The second one, flowchart symbol have any entry point on the top of the symbol with no other entry points. The exit point for all flowchart symbol is on the bottom except of decision symbol. The decision symbol has two exit points. These can be on the side or the bottom or one side. All flowcharts start with terminal and predefined process symbol. All flowcharts ends with a terminal or a continuous loop. That's a very basic general rules for flowcharting. Now some advantages. The first advantage is communication. A flowchart can be used as a better way of communication of logic of a system and steps involved in the solution to all concerned, particularly to the client of the system. Very effective analysis. Documentation of program is very easy if you are following flowcharts in your program. Effective program maintenance and coding of program. If you have algorithm of a problem or question or a flowchart, then coding is very easy. It's just a game of language. You can write that program in any type of programming language, same level of programming language. That doesn't mean that you are writing in C programming language or Java programming language, so you can also write an assembly programming language. No, on a same level programming language. It's very easy if you have the flowchart or algorithm of that problem. So it's a very basic thing for all those students, everyone who want to write a good program. So this is the end of today's class. If you like my class, then please subscribe my channel, like this video and share this video. Thanks for watching.